Welcome back to The Explainer. Today, we're jumping straight into one of the most elegant, visually satisfying concepts in all of microeconomics. We are going to definitively map out the consumer's equilibrium using the ordinal approach. Basically, we're going to build the exact architecture of consumer balance layer by layer. To ground ourselves before we start drawing, we really need to understand what the ordinal approach actually means. Unlike older economic models that tried to count exact utility numbers or utils, which, let's be real, is practically impossible to do in real life, the ordinal approach is all about qualitative preferences. It's simply about rank. We're looking at how a consumer maximizes their total satisfaction subject to a strict budget constraint just by ranking different combinations of goods. It's a beautifully structured framework of choice. Okay, let's dive into this. Here's our roadmap for the masterclass. First, the architecture of balance. Second, the two golden rules. Third, graph assembly. Fourth, analyzing the options. And finally, the big payoff, the tangency point winner. Section 1, the architecture of balance, setting the stage. Now, to build any lasting architecture, you absolutely need a solid foundation. And in economics, our foundation is always built on assumptions. For this to work, we must assume a few things are locked in. The consumer's income, given and constant. Their tastes and preferences, locked in. And the market prices of the goods, also given and unchanging. Without these strict constants, our geometric map would constantly be shifting around, and finding a true balance would be literally impossible. Section 2. The two golden rules. Axioms of equilibrium. For a consumer to hit perfect balance, two golden rules have to be met. Here's our first, and it's a massive central equation. The marginal rate of substitution of good X for good Y must perfectly equal the price ratio of those two goods. To put that in plain terms, the rate at which you are personally willing to trade, say, clothing for food without losing any satisfaction, that's your MRS, well, that must perfectly match the rate at which the market actually requires you to trade them based on their price tags. Your personal preference must mathematically align with market reality. And rule number 2. The indifference curve, which is what maps your satisfaction, must be strictly convex to the origin. It has to bow inward. This convexity visually represents the diminishing marginal rate of substitution, basically meaning the more food you get, the less clothing you're willing to give up to get even more food. Your willingness to substitute naturally changes as your inventory changes. Let's move to Section 3, graph assembly, and see how this builds. It's time to visually construct our economic map. We're going to assemble this graph layer by layer to lower the cognitive load and keep things crystal clear. First, we draw our axes. Then we overlay the budget line. And finally, we plot the indifference map. Step 1, we define our coordinate space. On the vertical y-axis, we're measuring units of clothing. On the horizontal x-axis, we're measuring units of food. Every single point in this entire space represents a very specific shopping cart bundle holding some unique combination of clothing and food. Step 2. We drop in the budget line, which we're labeling KL. Notice it's a straight, negatively sloped line. Why straight? Because remember, market prices are given and constant. This line dictates exactly what is affordable. Anything inside or on that KL line, totally within budget. Anything to the right of it, completely out of reach. Think of it as your financial force field. Step 3. We layer on the consumer's actual scale of preferences with an indifference map. Here we have curves IC1, IC2, and IC3. Remember that convexity rule we talked about? Notice how they all nicely bow inward toward the origin? Also, keep in mind that a higher curve always yields more satisfaction. So IC3 gives you significantly more happiness than IC2, which gives you more than IC1. Section 4. Analyzing the options. The process of elimination. Okay, we have our map. Now, we need to test various points on this graph to see if they actually meet our golden rules. We're going to compare the frustration of settling for less utility, which we'll see at points A and B, against the dream of an unattainable luxury, represented by point D. Take a look at combinations A and B. They sit perfectly on that straight budget line, KL. That means the consumer is spending all their given income. They are completely 100% affordable, but look at which curve they sit on. They're stuck on IC1, the lowest indifference curve on our map. So even though they're perfectly within reach, the consumer is being highly inefficient here. They're just not maximizing their satisfaction with the money they have. Now, what's really interesting here is point D. It sits way up on the highest curve, IC3. The utility there, absolutely fantastic. But look where it physically sits in relation to our budget line KL.
It's way out to the right, completely out of the budget constraint. It's a geometric impossibility for this consumer's wallet. Total pipe dream. So, we have a bit of a puzzle. Points A and B leave happiness on the table. Point D requires money the consumer simply doesn't have. If combinations A, B, and D are all eliminated, where on this entire map is our absolute maximum utility? Where is the sweet spot reachable within the budget? Section 5, the tangency point winner, the ultimate proof. This brings us to the grand reveal, the exact coordinate where human desire perfectly meets market constraints. Behold, tangency point T. We isolate point T right there on the central curve, IC2. Notice how the indifference curve IC2 comes down and just barely kisses the budget line KL. It doesn't cross it like IC1 did at points A and B. It just touches it. This is the absolute maximum utility the consumer can reach without breaking their budget constraint.
So the crucial point is, the math is literally proven by the geometry. At this exact tangency point T, the slope of the indifference curve perfectly matches the slope of the straight budget line KL. And what did we learn in our first golden rule? The slope of the curve is the marginal rate of substitution, and the slope of the budget line is the price ratio. Because the slopes are equal right here, MRS perfectly equals the price ratio. Equilibrium is mathematically achieved.
And this brilliantly illustrates the final output of our explainer today. By tracing down to the axes from point T, we lock in the ideal shopping cart bundle. To perfectly maximize their satisfaction, given their exact income and current market prices, this consumer must buy exactly OM units of clothing and ON units of food. The architecture of balance is completely, flawlessly realized right here. But, economics is a living, breathing thing, so I want to leave you with this to ponder. If your income suddenly doubled tomorrow, physically shifting your straight budget line KL way out to the right, how would the architecture of your indifference map interact with it to find a brand new tangency point? The geometry of choice never stops shifting, and honestly, that's what makes this field so endlessly fascinating. Thank you so much for joining me for this explainer, and keep exploring the balance in the world around you.